this will produce a new squared up matrix equation. And when we multiply a 2 by 8 times an 8 by 2, we're going to end up with a 2 by 2. So we hit equals, matrix multiplication, and we say we want to multiply the transpose times, comma, the original coefficient matrix. Hit Control Shift Enter. Now we've squared it up, and we've got a 2 by 2 matrix there. Okay, we still have our times, and we still have our A and our B. Okay. And then we have on the other side, we're going to get a 2 by 1 because we're going to multiply a 2 by 8 times an 8 by 1. And that will give us, when we do the multiplication, transpose times, comma, the constant of the original. Control Shift Enter gives us our new constant matrix. All right, now that it's all squared up, we're ready to solve. But before we can do that, we need to find the inverse of this new squared up coefficient matrix. Since it's 2 by 2, the inverse will also be 2 by 2. Equals minverse, the inverse, matrix inverse of this coefficient matrix. So we hit Shift Control Enter. There's the inverse. Okay, this is the key. Now we're going to multiply both sides of this equation by that inverse, and that will give us our solution. Let's see here, get these all kind of neatly done up. So if we're going to take a 2 by 2 times a 2 by 2, we will end up with a 2 by 2 equals matrix multiplication, the inverse, comma, times the original, or the, not the original, the coefficient matrix of the new squared up one. We'll take Control Shift Enter, and it should not surprise us that we got a identity matrix, a 2 by 2 identity matrix. Yes, that is 0 there. And then we still have our times, we still have our A and our B here, and let's make this one look like a matrix as well. And over here on this side, we're going to take this inverse times the constant, getting us a 2 by 1. So equals matrix multiplication, the inverse times, comma, the constant, and hit Control Shift Enter. All right, so what this tells us is, since the identity times anything does nothing, that leaves AB by itself, so AB is equal to this matrix over here, so A is about 4.8 and B is about a negative 0.97. All right, are we done? Well, no, we're not done. We want to come up here to where our equation is, and our regression equation will look like this. We'll have y equals and then our A is 4.8 approximately, divided by the quantity, okay, of x plus this negative, plus a negative would be minus, so we'll just put minus and then approximately 0.97. All right, that should be our equation, but let's just check it out to make sure. Come up here and make this column the check column. And in this column we'll put the formula equals. We want to check to see if we do this to our x, if we get the same or approximately the same y. So when we do that, we'll want this a value on top. So I'll come down here and I will hit A. Now I'm going to want an absolute reference rather than a relative reference. To do that on a Mac, the keyboard shortcut is Command T. Did you notice that it just put $signs in front of the F and the 41? That means keep taking this formula out of box F41. Okay? Then divided by the quantity, and we want x, so that's this value. This time I'm not going to use the absolute reference. I'm going to leave it a relative reference because when I copy this formula I want it to use this x. But I still want it to bring this a out of the F41, so that's why we put the $sign. Then here we're going to go the plus, okay, and I'm going to then put the b right there. So plus the negative 0.9 or whatever will, but this one I want to take out of this box all the time as well, so I'm going to go Command T. Now if you're on a Windows machine, that shortcut is the F4 is your shortcut on your function keys. Okay, now we hit enter, and I'm a little ways off, but let's fill this down and see how close this fit is. What we're saying is for this form of a rational, then this formula that we just put in here is the best fit we can get. All right. Now, if this data had been given to us in a real-life situation, we might ask questions. What might it be if I go beyond the data, if I use my formula to this regression to extrapolate? And we could come down here and put in, what if it were 8? And hit that, and you'll notice that it continues to get closer and closer to this asymptote. Or if I said, what would 3.5 be? 3.5, and I hit 3.5. This one is an interpolation, and I better be getting some value between 4 and 2. Let's see, 3.5 between 3. Well, we're actually between these two. And so that's how you would use your regression formula to answer questions about situations beyond the data or between the data points. So this is what we would expect from our regression formula. That's how to do a regression model, find a best fit equation for a rational function.